If you remember in class, I showed you two methods for doing this very question. First one is where you find the equation of the line, which goes through the origin. And is perpendicular to the plane, so we can get the direction from our equation of the plane. So that line would be lambda 2I minus 3j plus k. We then want to know what the point is where that line crosses the plane. So we're going to substitute the r with our line, and I'm going to change to working in columns. So 2 lambda minus 3 lambda lambda dot 2 minus 3 1 has to equal 5, and that happens when 4 lambda plus 9 lambda plus lambda equals 5, 14 lambda equals 5, lambda equals 5/14. So we now got to find the point on the plane. And the point in the plane, we know that lambda is 5/14, so the coordinate of the point on the plane, and I'm going to call it P, will be 5/14 of the x, which is 2, the y, which is minus 3, and the z, which is 1, which I have got from this formula here. We have the origin, which is at 0, 0, 0, and now we want to find the distance OP. So that will be 5/14 times the square root of 4 plus 9 plus 1. So that's 5√14 over 14. When you look at the mark scheme, you'll see the formula listed. If you want to learn that off, you can just use the formula. So we have an equation of a plane where r stands for x, y, and z, or xi plus yj plus zk, and the equation of a line. We'll start with the line, and if I put that equal to a parameter lambda, then I can see that x is 3 lambda plus 2, y is minus 2 lambda plus 5, and z is 5 lambda minus 1. I'm going to work now in column vectors, and if I replace the r with the x, y, and z, I know that when I do the dot product with 2 minus 3, 1, I have to get 5. So 2 times 3 lambda plus 2 minus 3 upon minus 2 lambda plus 5 plus 1 upon 5 lambda minus 1 has to be 5. 6 lambda plus 4 plus 6 lambda minus 15 plus 5 lambda minus 1 has to equal 5. So 17 lambda will equal 5 plus 16 minus 4. 17 lambda is 17, so lambda is 1. And substituting that in, our x coordinate is 3 plus 2, our y coordinate is 5 minus 2, and our z coordinate is 5, take away 1. So I want to start the next part by finding the angle between the normal to the plane. So that's 2 minus 3, 1, and the direction of the line, 3 minus 2, 5. If we do our dot product, then we have to have the magnitude of the first, so that's the square root of 4 plus 9 plus 1, 14. Square root of 9 plus 4 plus 25, 38 cosine of the angle between. Right hand side becomes 6 plus 6 plus 5 equals root 14, root 38 cosine theta. So the cosine of theta is 17 over root 14, root 38. Theta is 42.5 degrees. So that is the line between the perpendicular to the plane and the line. What we want is the angle between the plane and the line, so that will be 90 minus 42.5, and that gives us an answer of 47.5 degrees.